guys have seen and solved systems of equations before at some point in time. You've done this. Okay? You've done this. Now, when you did this, if you recall, there were 3 ways to set this up. How are the ways that you can do that? Substitution, yep. Elimination. Translation or something, or transformation, or I'm trying to remember what the T one is. Pterodactyl? It was me. I can't spell, so I would have said pterodactyl with a T. How about it was the all else fails was called linear combination. There's probably another name for it, but I grew up knowing it as called linear combination, where you multiply it to turn into elimination and whatnot. So before I do this, let's just briefly talk about the methods. We had substitution. Substitution, elimination, and then the last one is linear combo. Am I going to require that you do one method versus another? No, does not matter. At this point in time, you will see certain problems of saying, please use substitution for the following. That's stupid. Do whatever you think is going to work the easiest for you. Okay? Because in the grand scheme of things, when you're taking a final, if you're taking an ACT, you're taking an SAT, is somebody going to be staring over your shoulder, making sure you do it one specific way versus another? Sorry, I feel bad now. Anyway, substitution. Use substitution when a variable is by itself or can be. Can't write today. What I mean by that is if you have 2x plus y equals 6, I would just subtract the 2x and say y equals 6 minus 2y. Okay. If you can get it by itself easily. Okay. Elimination, there were 2 methods for elimination. You could add or you could subtract. Knowing what to do when is the trick. If you have the same coefficient, oh, what's that? What's coefficient? Yes. The y? Anyway, the coefficient is the number in front of the variable. The variable could be x, it could be y, it could be r, it could be q, doesn't matter. So it's the number in front of the variable as your coefficient. So ish. Okay, I didn't understand your brain yet, so we're still learning it. So if you have the same coefficient with the same sign, 2x, negative 2x. If I add those two together, I would be able to eliminate them. I'm sorry. Same. If you have 2x and 2x, if I subtract them, I was thinking ahead of myself. They would eliminate. I'll show you examples of all this. And then if you have same coefficient, opposite signs. And then the last one is like the idea of all else fails. You want to multiply by some common value to create elimination. So linear combination is the multiply, and when I say multiply, I can multiply everything by 2. I can multiply everything by a third. It's the same thing as divided by 3. You can do any of that. Multiply by some factor to be able to eliminate. Okay. Again, once we throw a couple examples on the board, you'll go, oh yeah, I remember that, and it's fine. Okay. The biggest mistake that people make with these types of problems is that when you distribute, you'll forget to distribute two terms within a parenthesis. Or my suggestion a lot of times when we write this stuff down, don't write it so narrowly together. Space it out a little bit so you have a little bit of room with all the different signs that you'll have, so you can break it into separate problems and so on. So that's basically solving system equations in a nutshell. When you have system equations, you've got two equations, two variables. You're looking for where two lines intersect. So two lines can intersect. When they intersect where? At a point. Good. So points are written as ordered pairs, right? Okay. So you can have a point that intersects. What happens when lines are parallel? They don't intersect, so you have no solution. What happens if it's the same line? They're equal, and we would say infinite solution. Okay. But yeah, you get a true statement. As we go through these, you'll come across them going, wait, why does 5 equal 5? Well, that's because it works. Back to this. When I look at this problem here, 3x plus 4y is -4. X plus 2y is 2. Which method do you want to use? I would use substitution. In my mind, I would use substitution here because I've got x that has a coefficient of 1, and I can get it by itself pretty quick, just moving the 2y. So I can say that x is 2 minus 2y. So I put the -2y in front of the 2 and write it like that. If you do it this way when you're subtracting, you'll be less likely to forget that it's negative. So it's the top tip. Which means now, everywhere I see an x, I'm going to substitute in and put 2 minus 2y. Yeah, 3 times the quantity plus 4. Bless you. Distribute. What's 3 times 2? 3 times -2. Combine like terms, you might have a pretty quick problem. -6 and 4 is -2. You can do one of two things here. Subtract 6, divide by -2, or add the 2y, add the 4. Depends if you're a negative person or a positive person, what you wind up with. Myself, I am such a positive person. Shut up. I know. As the shirt says, I'm a jerk. I'm no math major. Yeah, y'all should be a lot. So that means my value of y is 5, which means my value of x, what do I do to figure that out? Substitute back in. And you get 2 minus 2 times 5, otherwise known as. Very good. So your two lines intersected, they intersected at a solution set. The solution set here is called an ordered pair. means what comes first, the -8 or the 5? Because the -8 is corresponding to the. So your answer would be -8, comma 5. Okay? Not bad, right? Rings some sort of a bell? Okay. Okay. Then, since you guys know how to do all this, do this one. Now, in my mind, in my head here, I see that you can do one of two things. First thing I'll do is answer the door. Second thing I'll do is say, can I multiply this whole bottom equation by a half and get x plus y is -5? I can do that. Divided by 2 means the same thing. Or, could I just multiply that top equation by 2? Now, when I see this, I would probably do that. I would multiply this whole top equation by 2, which means I have to multiply all parts by 2. And then I'm going to rewrite it below the other equation. And I'm going to get 6x minus 2y equals 26. I have the same coefficients now for the y's, don't I? I have opposite signs, don't I? Same coefficient, different signs. What do I do to get rid of them? Add them. And this is where it comes into the idea that I'd ask that you guys try to write it a little bit wider, because now I have 3 addition problems. By writing it out a little bit wider, it gives you a little bit of space to put in here. Well, now I have 2x plus 6x, 2y, plus a -2y, -10 plus 26. What's 2x and 6x? 8. Good. 8x. These guys cancel out. And I get a 16. X is 2. Now, if x is 2, what do I do to figure out y? Substitute back up. Does it matter which of the equations I use? Nope. I'll go here. If I go there, I get 2 times 2 plus 2 times something is -10. What's 2 times 2? 4. To move that to the other side, you add it or subtract it? Subtract. What's -10 subtract 4? Good. Therefore, y is. So did your answer check out? So your answer would be 2 and 7. Could you have done something different? Could you have done substitution, moved the y over, and moved the 13 back? Sure, you would have gotten all the same thing. I would try to stay away from substitution more often than not, unless it's pretty obvious it's the only one that's going to work cleanly. But yeah, it looks like. Nothing. No, there's nothing wrong with it. I just, when I know that substitution goes on here, a lot of times that I know what students will do is that they're going to say it's 3x plus 13 is y, because you added the y over, which means you had to add the 13, so you get that part wrong. So the less moving parts that I have, the easier it is. That's how I've always approached it. I'm not going to say that it's wrong for anybody to do that method. If you are just hell-bent just to go for it, do it that way every time, fine. I have no problem with that. Especially if you can just move it, but just pay attention to your signs as you're moving things back and forth. I have no problem with that. I'm not going to say one way is the absolute versus another. Okay. It's just, after doing it for a while, you kind of learn where people are going to make their mistakes. You'll hear me say that a lot. This is where you're going to screw up. Don't screw up. Elimination will be if you have the same coefficient, same side, same size, yeah, same coefficient, same sign, subtract. Because I have the same coefficient, opposite sign. Yeah. Okay. I have another one in here. There's no right or wrong way of going about it. There really isn't. It's all up to you what you see first. Okay. This is one of those things that there's no right way to start. Okay. Sometimes you do. Sometimes you have to do that. You can match up either one. It doesn't. When it comes down to elimination, you can get rid of whichever one you want to get rid of first. It's solely, totally, completely up to you. It's not a big deal. Okay? Not a big deal. I'm going to show you a funky way to do this one. I'll be right there. Dude, this is oh, you know what, John? I told you I was going to be there. You didn't hear that. What do you got? Who's this? Oh, I think you're doing it. I'm sorry. And fix that you pilot. Hey guys, is it okay to get decimals or fractions? Yes, it's okay. It's not the end of the world. It happens. For example, let me show you something that's going to be kind of crazy. Now, if I divide the whole bottom equation by 5, I'd get negative x plus y and 3, wouldn't I? Yes. But then I'd have to do something else to make it match up with the 2's and the 3's, wouldn't I? So when you divide by 5, what's the multiplication way of saying that? Times 1/5. So what if I did this? It's up to you. It's just another way of doing it. Now guys, now watch what happens. If you did it, how many of you guys multiplied the top one by 5, the bottom one by 2? That's the most common way that you'll see it. How many of you guys divided the bottom one by 5 and moved the x? It works too. Did you guys multiply the top one by 5, the bottom one by 3, and try to subtract that? Okay. There's many ways. Me, I see these are all divisible by 5, which means I can multiply all of them by a fifth. But then I'd have to get rid of the x value or the y value anyway. So by multiplying by a fraction, it's a shortcut way of doing it. So I'd have 2x, 3, let me space this out, plus 3y, negative 1. Then I get negative 2x, plus 2y, and then that's 5, 3 equals 6. Same coefficient, opposite signs with the 2 x's. Add the equations together. Also, you'll notice when I split these things into 3 parts, notice where I put my first bar. I put it prior to whatever the sign is of that second term. That way I know to keep that sign with me. So I get 2, oh, these are all plus. 2x plus a negative 2x. These are gone. Did you get 5? Yes. That's fine. Okay. So I got y for 5. I was making sure that you guys are paying attention. Good work. Nice job. Good work, ladies and gentlemen. Guys, hold up. Give me 1 second to finish out the X value real quick. So now that we've all agreed that 5 divided by 5 is 1, not 5, like I was checking to see if you guys are paying attention, because I would never make a dumb arithmetic mistake. Ever. 2x plus 3. What's negative 1 minus 3? What's negative 4 divided by 2? So our ordered pair would be at negative 2 and 1. What do you got, Dan? When you get into this style here, remember, if you're adding one of them, you have to add all of them. You can't just pick and choose. Okay? Otherwise, you're really going to goof up. Will you get fractions? Will you get decimals? It's fine. It doesn't necessarily mean you screwed up. If you get a fractional answer, for ordered pairs, can't you just substitute it back in the calculator, see if it works? How do you make a fraction part of that calculator again? Alpha y equals. Yeah, alpha y equals enter, and then I get you there. Okay. I believe I already posted the 7 of these I asked you to do. In the text, it's on the calendar, and I'll put it up here for you so you can start working. I had you guys do 36 through 48 evens in the section that's on the calendar. It's at 3.2. So it was 36. One thing I will remind you guys of, this is the section, these next few sections out of the textbook are where it is so easy to write down the first equation of the problem you're working with and then accidentally read the second equation from a different problem. So when you're doing number 36, kind of cover up your screen if you have to, just so you make sure you write down the correct parts. It happens, okay? It happens. It'll happen to somebody in here. It'll happen to somebody in first hour. It happens all the time. Just like 5 divided by 5 is 5. Just in case. Okay? this. Well, I'm sorry that I'm sorry you got all excited for a second, then I realized that I can't math. It gets late in the day, I guess my math. There's infinite amount or finite amount of mathing skills. I might be running low on that. Yeah, I probably can't math that either. Let's fake it. So please, quietly, let's get going. We got a couple minutes to get started.